Our next example problem asks the following. An unknown gas has a mass of 0.50 grams. It occupies 1.5 liters at a pressure of 252 torr and a temperature of 243 degrees Celsius. The empirical formula of the unknown gas is C2H5. What is the molecular formula of the unknown gas? Okay, so we can go through here and we can solve for various things here. Remember that from the previous example problem, our molecular weight is going to equal grams per mole. In this particular case here, we're given the amount of grams and we need to solve for the number of moles. So we can use the ideal gas equation in this case to solve for that. So we're going to use PV equals nRT, and we're going to rearrange this to solve for N, which will be PV divided by R times T. Now remember, when we write this in, our value for R is going to be 0.0821 liter atmospheres per mole times Kelvin. So all of our units, in order to cancel out everything here, we're going to need our volume in liters, our pressure in atmospheres, and our temperature in Kelvin. So our pressure is given in 252 torr. So we're going to need to convert this to atmospheres. So 1 atmosphere is 760 torr. Next, our volume is given to be 1.1 liters. So we don't need to do anything to convert that. And our temperature is given to be 243 degrees Celsius. We need to convert that to Kelvin by adding 273. So if we go through here and we solve for N, we get 0.0086. The torr units cancel, the atmospheres cancel with our R constant, the liters cancel with the R constant, and the Kelvin gives us our R constant. We have moles to the -1 in the denominator, so when we flip that up to the numerator, our units are going to be in moles. So here we have 0.0086 moles. Again, our molecular weight is going to be given in grams per mole. We are given in the problem that this gas is 0.050 grams divided by 0.0086 moles. If we solve for this, we get a molecular weight of 58.07 grams per mole. If we look at this gas, we're told it has an empirical formula of C2H5. So if we wanted to determine our empirical formula weight, it's going to be 2 times 12 plus 5 times 1.00. This is going to give us an empirical formula weight of 29 grams per mole. If we remember back on how to, compare an empirical and a molecular formula, okay, we do this by looking at a factor. So if we take this 58.07 grams per mole and divide it by 29 grams per mole, we are roughly going to get a factor of 2. So we need to take our empirical formula of C2H5, multiply that by 2, which gives us a molecular formula of C4H10. And that is going to be our answer. So if we look into this, in this case, when we try to determine our molecular formula, we need to figure out what molecular weight we have. We can do that by using the ideal gas equation, getting the number of moles, taking the grams that we're given, divide by that number of moles to get the molecular weight of this particular unknown, and that will be 58.07 grams. We're given our empirical formula to be C2H5. We've determined the empirical formula empirical formula weight, which is 29 grams per mole. If we take the value we determined, our 58.07 divided by 29, that gives us a factor of 2. So we need to take our empirical formula, multiply by that factor to give us C4H10, which is the correct answer for this particular example problem.